Welcome to our next video of real number. This is second part. So far we have studied about number system. In this video we shall study deeply about terminating and non-terminating number. Let's understand the various categories of number that comes under the real number. Real numbers can broadly be classified into rational number and irrational number. We have already studied in our previous video that real numbers can be classified into rational numbers and irrational number, कि हम अपनी वास्तविक संख्याओं को परिमेय संख्या और अपरिमेय संख्या के रूप में विभाजित कर सकते हैं. Irrational numbers like √2, √3, pi, etc. These numbers means irrational number. These numbers cannot be expressed in the fraction form like p by q. They are also called non-terminating, non-recurring decimal numbers. On the other hand, rational numbers are broadly classified into two types. Fractions. Like p by q. And second, integers. First of all, we shall discuss about the fractions. Fractions like p by q or fractions are sometimes refers to non-integers like 2 by 3 minus 17 by 12. Numerator and denominator have to be integers. In the fractions, numerator and denominators have to be integers, and p by q cannot be anything like √2 or pi. On the other hand, integers are basically fraction with denominator as 1. Integers further divided into two parts. Negative integers and 0 and positive integers. Negative integers like -3, -27, -104, etc. Integers further classified into two parts, negative integers and 0 and positive integers. And in these categories, we find whole numbers which start off 0, 1, 2, 3, 4 and so on to infinite. So whole numbers include all positive integers along with 0, and the positive integers 1, 2, 3, 4 and infinitive have a special name natural numbers, which include all positive integers starting from 1. So real number pretty much include all the numbers that you are seeing. All numbers which can express as p by q is called rational number, and which cannot be expressed as p by q is called irrational number. All the categories which you are seeing are given one letter name. Real numbers are denoted by capital letter R. Rational number are denoted by capital letter Q. Irrational number are denoted by capital letters P. Integers are denoted by capital letter Z. Whole numbers are denoted by capital letter W. And natural numbers are denoted by capital letter N. Now, can you tell about what is not a real number? So, square root of negative numbers are not real numbers. Square root of negative numbers are not real numbers, such as square root of -1, square root of -4, etc. These numbers are not real numbers. They are also called unreal number or imaginary number or complex number. Let's understand this chart diagrammatically. Let this be an entire set of real numbers. With real numbers, we have rational numbers and irrational numbers. This is the set of rational number and this is a set of irrational number. Within rational numbers, we have integers. And within integers, we have whole numbers. And within whole numbers, we have natural number. So everything seems to be a real number. We can understand about the rational numbers and irrational numbers through decimal expansions. As we know that a rational number is the number that can be expressed in the form of P by Q, where P and Q are integers and Q not equal to 0, and P and Q have no common factor other than 1, or a rational number is the number that can be expressed in the form of P by Q, where P and Q are co-prime. Do you know what is a co-prime? Means two natural numbers whose common divisor or SCF is 1, called co-prime numbers. To decimal expansion of a rational number is either terminating or non-terminating recurring. First of all, we talk about terminating decimal expansion. If the decimal expansion of a rational number terminates then the prime factorization of Q is in the form of 2 to the power m, or 5 to the power n, or 2 to the power m multiplied by 5 to the power n, where m and n are non-negative integers. For example, 3 by 8, 13 by 125 and 17 by 200, etc. Now look, 3 by 8, its decimal expansion will be 0.375, and the prime factorization of 8 is 2 multiplied 2 multiplied 2 means equal to 2 to the power 3. Second, 13 by 125 and its decimal expansion will be 0.104, and the prime factorization of 125 is 5 multiply 5 multiply 5 means 5 to the power 3. And third, the decimal expansion of 17 by 200 is equal to 0.825, and the prime factorization of 200 is 2 multiply 2 multiply 2 and multiply 5 means 2 to the power 3 multiply by 5 to the power 2. So without doing long division, we can say that the decimal expansion of a rational number is terminating if the prime factorization of denominator is in the form of 2 to the power m or 5 to the power n, or 2 to the power m multiplied by 5 to the power n, where m and n are non-negative integers. Is there some obvious reason why this statement is true? Yes, any rational number of the form a by b, where b is a power of 10, will have a terminating decimal expansion. 3 by 8. If we get the prime factorization of 8, we get 3 upon 2 to the power 3. So, making its denominator the power of 10, we shall multiply its numerator and denominator by 5 to the power 3, 5 to the power 3. Then we shall get 375 upon 10 to the power 3, and the decimal expansion will be 0.375. We are seeing here that 10 to the power is 3, so the number will terminate after 3 digits, 375. Secondly, 13 by 125. So the prime factorization of 125 will be 5 to the power 3. So to make the denominator 10 to the power, we shall multiply the numerator and denominator by 2 to the power 3, both numerator and denominator, and we shall get 104 by 10 to the power 3. So once again, the decimal expansion will terminate after 3 digits of decimal, and we will get 0.104. Third, 17 by 200. So the prime factorization of 200 will be 2 to the power 3 and 5 to the power 2. So to make the denominator 10 to the power, we shall multiply the numerator and denominator by 5. So we shall get 85 by 10 to the power 3, and the decimal expansion will be 0.085. So these examples show us how we can convert a rational number of the form of P by Q to an equivalent rational number of the form A by B, where B is a power of 10. Means if we convert a rational number like P by Q equivalent to a rational number A by B, where B is a power of 10. So we shall get the terminating decimal expansion. Conversely, if the prime factorization of denominator of a rational number is in the form of 2 to the power m or 5 to the power n or 2 to the power m multiplied by 2 to the power m multiplied by 5 to the power n, where m and n are non-negative integers. Non-negative integers, then the decimal expansion will be terminate. B. If the prime factorization of denominator of a rational number is not in the form of 2 to the power m or 5 to the power n or 2 to the power m multiplied by 5 to the power n, where m and n are non-negative integers, then the decimal expansion will be non-terminating recurring or repeating. For example, 1 by 7, 11 by 9, 13 by 6, 17 by 21, 13 by 15, etc. The decimal expansion of 1 by 7 will be 0.142857, 142857, and so on. And it can be right 0. 0.142857 bar. 11 by 9 equal to 1.2222 and so on, and can be right 1.2 bar. Similarly, 13 by 6, the decimal expansion of 13 by 6 is 2.1666 and so on, and can be right 2.1 6 bar. Similarly, 17 by 21. The decimal expansion of 17 by 21, 0.809523, and then repeat 809523 can be write 0.809523 bar, and 13 by 5 equal to 0.8666 and so on, that can be written as 0.86 bar. So we can conclude that decimal expansion of every rational number is either terminating or non-terminating recurring. Now we are talking about some irrational number. The decimal expansion of an irrational number is non-terminating, non-recurring. As we have already studied that the decimal expansion of root 2 equal to 1.41421356 and so on, and the decimal expansion of root 3 1.73205080 and so on. Root 5 equal to 2.236067 and so on, and the decimal expansion of root 6 equal to 2.4494 and so on. Similarly, the decimal expansion of root 10 equal to 3.16227766 and so on. And the pi, the decimal expansion of pi 3.141592 and so on. And some other types of rational number, you can see that just like 0.10, 100, 100, 100 and so on, and 0.120, 1200, 12000, etc. All these types number are called irrational number. So the remaining topics we will study in our next video. So stay tuned with us for more videos and subscribe our channel. Thank you.